Okay, let's do contingency tables, and I'm going to do exactly what the book says so you can follow the step by step. Contingency table is when we have two variables. In this case, they are dealing with customers in a restaurant that either they ask for fish or meat, and they are either satisfied or not satisfied with their food. Okay, so this is the data. They are satisfied or unsatisfied, and they either ask for meat or fish. And the purpose of contingency table is what? Is to get probabilities from frequencies. So we have a total of 200 customers, and the frequencies are as follows. Satisfied 70, that is meat, and unsatisfied 10. That is fish, 100 versus 20. Okay? So we have the frequencies. Okay, let's go to the totals. How many ask for meat? How many request meat in their lunch? 80, a total of 80. How many fish? 120, I'm sorry about that. So, it seems that the fish is more popular in that restaurant. Okay, how many were satisfied? 170. How many were not satisfied? 30. Okay? Now, from these, we are going to get probabilities. What is the probability that someone eat meat and was satisfied? What is the probability? 70 divided by 200. That is the probability of, if I pick one random customer, what is the probability that that customer is request meat and was satisfied with the meat? 70 over 200. That are the probabilities. What is the probability that that person ate meat and was unsatisfied? 10 over 200. And the same thing happened with this, 100 divided by 200, and this is 20 divided by 200. Now, what is the probability that the customer asks for meat? 80 divided by 200. For this, ask for fish, 120 divided by 200. And this is 170 divided by 200, and this is 30 divided by 200. Okay? So, these are probabilities. And that's very easy to get. I mean, is the total divided, is the number of that particular sale divided by the total. That's easy. If I add all these internal probabilities, has to be what? Equal to 1, because there are no other possibilities. So, let me get this. This is 0.35, this is 0.05, this is 0.50, and this is 0.1. So 0.5 plus 1, 0.35, and 0.05 is equal to 1. So there are no other probabilities. What about this one? 80 divided by 200, this is 0.4. And this is 0.6. If I add this, 0.4 plus 0.6 is equal to 1, because there are no other probabilities. I mean, we don't have chicken. We only have meat or fish. Okay, what about this one? This one is 0.85, and this one is 0.15. And 0.85 plus 0.15 is equal to 1. Why? Because we don't have customers that say so. They are either satisfied or unsatisfied. Okay? Now, that are inside, these probabilities are called joint probabilities. These probabilities that are on the margins are called what? Marginal probabilities. Okay? So the inside probabilities are joint probabilities, and the outside or margin probabilities are called marginal probabilities. Now, if I ask you, and remember, I mean, the internal probabilities or joint probabilities are the one that is going to have the intersection. What is the probability that the person it meets and is satisfied? Meet and satisfied? What is the probability? Meet and satisfied. What is the probability? If I pick one customer randomly, what is the probability that that customer ate meat and it was satisfied? 0.35, right? So the joint probabilities are the intersection probabilities. Now the marginal probabilities. What is the probability that the person ate meat? How many ate meat? 80, right? So what is the probability? 0.4. The marginal probability is the probability that the person ate meat. What is the probability that the person was satisfied? What is? It really doesn't matter what he asked for, meat or fish. What is the probability that the customer is satisfied? Satisfied, the whole row. 0.85. So you see, marginal probabilities tells you the probabilities that it really doesn't matter about the other table. It's the whole thing without considering the other variable. Okay? So if I ask you, what is the probability that the person eats fish and is unsatisfied? What is that? And intersection. So if you see an intersection, you know that is a what? A joint probability. What is this probability? Fish and unsatisfied. What is the probability? Fish and unsatisfied. This over here, right? Okay? It's 0.1. What is the probability that the person is satisfied given that he or she ate meat? Okay? Then we are going to apply what? The multiplication rule, and we're going to say that is the probability that is satisfied and eat meat divided the probability that he or she ate meat. Okay? The given that, remember, this is the multiplication rule, and you're going to use it when you need to find out what is the conditional probability. And the probability that is satisfied and meat is what? We already covered that. It's 0.35. Divided the probability that he or she ate meat is 0.4. So this probability is equal to. So you see, with the contingency table, it's pretty easy to 0.875. Okay? So the probability that the person was satisfied given that he or she ate meat is 0.875. Okay? What is the probability that the person was satisfied or eat meat? It's not in the book, but I'm going to tell you. In this case, you're going to use what? the addition rule. Whenever you see a union, you use the addition rule, and that is equal to the probability that is satisfied times the probability that he or she admits minus the probability that is satisfied and meets. Okay? So the numbers are there. Probability of satisfied is 0.85 plus meet is 0.4 minus the probability of satisfied and meet is minus 0.35. So you see how you handle probabilities using the addition rule and the multiplication rule. 0.85 minus 0.4, 0.85 plus 0.4 minus 0.35 is equal to 0.9. Okay? So you need to really see what the problem is asking you. Is this a union? Use the addition rule. If it's an intersection, use the multiplication rule. If it's a given or a conditional probability, you use the multiplication rule. Because the multiplication rule uses both the intersection and the conditional probabilities in the same equation. Any questions on this? I mean, it's pretty easy. It's just getting the frequencies to get probabilities and understand that the internal probabilities are the union or joint probabilities, and the marginal probabilities are the what? The probabilities that the variable occur without the other variables to be considered. Okay. The last point in the chapter is about counting. Counting. Why we want to count possibilities? We want to count possibilities because if we know how many possibilities we have, we then are going to understand what is the probability, or how many ways we can handle a few objects or whatever. That is counting. And it's important in probabilities. Why? Because that is going to be the probability. Counting. We have what I call the multi-step experiment. If we have an experiment with multiple steps and we want to know how many possibilities we have at the end, it's called the multi-step. And the number of possibilities, depending on the choices on each one of these steps, is K1 times K2 times K3 times whatever, depending on the number of steps. For example, if I go to a restaurant that has 3 types of beverages, 3 types. They may have tea, they may have Coke, or they may have Diet Coke. Right? I don't know. They have the main dish. They may have meat, they may have fish, or they may have chicken. Or what? What else? Pizza. 4 types of main dishes. And dessert. They may have what? Ice cream or pie. Only 2. I want both. You know, I'm hungry. But anyways, okay, let's say that they have 2 possibilities. Now, how many different possibilities I can get with these steps? How many times I can go to that restaurant and have different things without repeating? Okay? According with the multi-step, we have K1 times K2 times K3. So beverage, we have 3. Dishes, we have 4. And desserts we have 2. So it's 3 times 4 times 2 is equal to 36. No. 24, right? Yes, 24. We have 24. So I can go there 24 days without repeating something. So the first day I asked for tea and fish and pie. The second day I might ask for tea but meat and ice cream. The third day I'm in to 24 possibilities. Believe me. I'm not going to do that here, but believe me. There are 24 possibilities because it's 3 times 4 times 2. So in every step, we are going to have the number of possibilities. So we just multiply each of the possibilities and we're going to get the possible number of different combinations. Okay? The next one is what is called the permutation and combinations. Okay. What is permutation? Permutation and combination. These are pretty easy. Why? Because permutation is when I select, both is select X objects from a pile of N objects. I want to know how many combinations, permutations, what we can have. Now, what is the difference between permutation and permutation and combination? In permutation, the order is important. In combination, the order is not important. Okay? So let's say that I have 50 students and I want to take 3 of my students to Orlando, I guess. Okay? How many possibilities I have? Now, the first question, is the order important? All of them are going to Orlando. Is the order important? The order is not important. So we're going to use what? Combinations. But let's say that the first, that I'm going to select 3 students and I'm going to give it the first prize, Las Vegas, second prize, New York, and third prize, Atlanta. In that case, selecting students, the order is important because each one is going to receive different things. So it doesn't, how many different combinations I have where the order is important or not important. Okay? For permutations, the formula is n factorial divided by n minus x factorial times x. No, that's it. In combinations, the formula is n factorial divided by n minus x factorial times x factorial. Okay, what is this factorial? What is factorial? You know what is factorial? X, I'm going to erase this. X factorial is equal to x times x minus 1 times x minus 2 times 1. So 5 factorial is equal to 5 times 4 times 3 times 2 times 1. Okay? By definition, 0 factorial is equal to 1. By definition. So, let's say that I have my 50 students. So, 50 students, and they are going, 3 are going with me to Orlando. How many possibilities I have? Okay? Now, are you using permutation or combinations? Is the order important, yes or no? The order is not important, so we are going to use what? Combinations. Let's go to the formula. N, how many students? 50. 50 factorials divided by 50 minus 3 is 47 factorial times 3 factorial. 50 factorials. What is 50 factorial? I mean, 50 times 49 times 48 times 46, 7 times 46, and so on and so on and so on. But what is 47 factorial? It's 47 times 46. So really, this goes away with each other, sort of. Anyways, I mean, I just want you to know these possibilities. Anyways, in your TI-84, how can you get combinations? You can do that so let's say 50 combination. So from 50 I'm going to get 3. That's the notation that the TI-84 and your book uses. From a pile of n, I'm going to select, using combinations, the x number of elements. So I have to say 50, then math, go to probability, hit enter. Hold on. No. It's 50, math, go to probability. Then go to combination, that is number 3, if you are following me. Then enter and hit 3 and hit enter. It's going to be 19,600. So I have 19,600 different ways that I can select 3 students from a total of 50. A lot. Right? You got it? So, let me say over here, if I go to the camera, guys, this video is in YouTube anyways. Go to 50, then math, go to probability, then go down to combination, hit enter, then hit 3, enter, and you're going to see the 19,600. If you have a non-fancy calculator like the one I have, it's just, I have this 260, and it's nothing but 50, shift, combination over here, 3, enter, is the same 19,600. Okay, so in this FX 260 you have the same function. And for permutation is exactly the same. You have the permutations in your, and in permutation that one is 50. So let's do the permutation. When one goes to Las Vegas, the other 2 New York, and the third goes to Atlanta. So the order is important. So in combinations for that particular thing, I have 19,600. Now, what happened with permutations? So let's do permutations. So it hit 50, math, probability, then go to permutation, enter, hit 3, enter, and it's going to be 117,600. 170,600 possibilities that I can choose. 3 students from a pile of 50 students and going one-to-one different ways. Okay? So that is, and you know, why do you want to do that? Because again, if you know how many possibilities you have, you would know what is the probability. like winning the Georgia lottery. Someone can tell me what are the rules of the Georgia lottery? You have to pick what? 5 numbers? You have to pick 5 numbers from a pile of how many? 60, 65, 64? I don't know. Let's say 60. I don't know. But let's say that we have 60 numbers and we have to select 5 numbers of those 60 in order to win the big bucks. Okay? What would be how many possibilities I have? First of all, is the order important? It's not important. Because we select the numbers. I mean, the numbers are not repeated. So the order is not important. So if the order is not important, what we're going to use? Permutation or combination? Combination, right? The order is not important. So I'm going to select 5 from a 65 numbers. What is this number over here? I don't know. It's 60. We say combinations. We have to select 5. Oh my God. This is 5,461,512. These are the combinations of selecting 5 numbers out of 60. I mean, I really don't know what the real rules are. So the probability of getting the jackpot or the lottery is 1 over 5,461,512. That is the probability to win the lottery. Okay? So it's pretty small. Is 60 combinations, 5. The probability is equal to 1.83 times 10 to the power of minus 7. Ooh, what is that? Do you know this? I mean, do you know how to handle this number? Okay, this minus 7 means what? That you have 1.83 and then you have to move to the left 7 spaces or 7 decimal points. So it's 1, 2, 3, 4, 5, 6, 7. So this number is 0.000000183. That is the probability to get the lottery. Wow. It's pretty small, right? But someone said, well, somebody got it, right? Somebody else won the lottery, of course. And that's why we tend to play. But the probability is 0.0000001. So 1 every 5 million times that you play, you're going to win. That is the probability. Okay? So, you see, that is why we use permutation, combinations, kind of things, because knowing how many possibilities we have, we are going to get the probabilities of getting something. Okay? That's it. That ends the chapter.